I'm very happy to have this opportunity to give a talk here. Okay, I'm going to present some of our study about learning behavior and the interactive pattern analysis. Why learning analytics is so important in to e-learning researchers? I think most of the previous study of e-learning mainly use pre-test, post-test, pre-questionnaire, and post-questionnaire to evaluate students' learning performance or perceptions. Okay, so if we can analyze their learning process, including their interactive behavior or their learning behavior, we can learn more, and we can know more about what happened during the learning process. Okay, so for example, we can answer some questions we cannot answer before, such as what have the high or low achievement students done during the learning process. We can also have in-depth discussion when we try to explain why some group learn better than the other groups. And before doing that, the first thing we need to do is to define a coding scheme. A coding scheme is a set of codes that can be used to transfer those learning behaviors or interactive content which are ill-structured into some unified and meaningful categories which are structured. For example, when we develop a role-playing game, the learner usually walk in a game. Sometimes there are some NPC. NPC means a non-person character. That means the character controlled by the computer. Okay. So when a player approach to some NPC, means that he or she might want to seek hints or help from those characters. Okay. So if the learner or the player do that, then we categorize those behavior into a code we say might be seeking help. Also, in some role-playing game, the learner or the player might go to a bookstore or library to find some material because they need to know more so they can go to pass the game. So if they do that and go to a bookstore or a library to read some material, and then we say that they are trying to learn something, okay, during the gaming process. So usually those behavior need to be coded manually if we do not predefine those behavior or those content when designing or developing a game, or if we use other people's game to do that. Okay, so in that case, we need to code manually by 2 persons based on the coding scheme we defined, and then we need to calculate if the kappa value is big enough. That means if the 2 coders have the consistent coding based on the learning content or the interactive content. If the coding scheme was embedded in the learning system or in the game, then of course we don't need to code the behavior or content manually. So coding scheme is very useful, not only for learning analytics. Okay, it can also be used for other purposes. For example, if we want to evaluate students' higher order thinking, such as their critical thinking or their problem-solving competence, we might analyze students' learning diary or their report or their feedback to some open-ended question, or what they have said or what they have done during the learning process. Okay, and let me give you some example. For example, if you want to evaluate student critical thinking, then what should we do? The first thing we need to think is about what kind of behavior will a student appear if they have high critical thinking. Okay, So someone might say, okay, the student with high critical thinking competence might have a reasonable criticize on something, okay? And they maybe might want to make more comparison, okay, on others' opinion. And then they might be able to provide the in-depth opinion or inference during the maybe discussion, okay? Or they might just provide some straightforward opinion. Okay, if this is true, if we accept that, okay, the student with higher order thinking have those behavior, then we can define a rubrics based on that, okay? So then we can analyze student interactive content or their learning diary or their report or something else, and based on this coding scheme and to give a rating about their critical thinking, okay? So this is another usage of a coding scheme. And in the following, I would like to introduce a frequently adopted coding scheme called the IAM, Interaction Analysis Model. It is proposed in 1997, okay? In this coding scheme, it consists of 5 phases to describe what happened during the student's interactive interaction in a maybe online discussion forum or in a MOOC system, okay? So it consists of 5 phases, and each phase consists of maybe 3 to 5 coding items. So the coding scheme consists of about 20 coding items. For example, the first phase is about sharing or comparing of information, okay? One of the examples, the 5th coding item of the first phase is define or describe or identify a problem. And the second phase is related to discovering or explaining the inconsistency among idea, concept, or statements. The third phase is about negotiation. And the fourth phase is related to testing or modification or reconstruction based on maybe the negotiation result. And the 5th phase is to reach an agreement based on the peer discussion. Of course, usually 20 coding items are too many for most of the research, because if you want to code that manually, then you have 20 coding items and you need to check every sentence of the student, and then you need to choose one of the items to categorize the sentence into that item. That will be very difficult. So most of the study adopt a simplified coding scheme based on IAM. For example, in 2008, Ho, Zhang, and Song have a study using a simplified coding scheme. There were only 5 coding items. Okay, the first one, P1 is propose, define, and clarify a problem. P2 is providing a solution, and P3 is compare the solution from peers, and the P4 is organize and reach a conclusion. Okay, and P5 is the discussion irrelevant to the issue there. Okay. Okay, so I'm going to present you a study made by Professor Yang Steven and me, and of course our student. Okay. In this study, we try to engage students in an AR-based augmented reality-based collaborative inquiry learning activity. Okay. We also use the same 5 coding items as Ho, Zhang, and Song. Okay. P1 is raise a question. P2 propose a solution. P3 compare or discussion the solution proposed by peers. P4 reach a conclusion or agreement. P5, okay, chatting. Talking about something irrelevant, unrelated to the discussion topics. Okay. So in this inquiry-based learning activity, the student use an AR, and a tablet computer with AR app in Couch Garden. So First, the students are guided by the learning system to make observation using the AR on the tablet computers, and they need to answer some questions, and they need to collect some data. Okay, and then of course they can make some annotation, and then they give some comment about what they have observed, and then they upload their finding and share their finding with the classmates. And then they go to a discussion forum to make discussion based on the question raised by the teachers. So we have designed an experiment to do that. The experiment group used the location-based AR during the learning process. And the other group using just a tablet computer to learn in the same environment. And then we have pre-test and post-test. Of course, we try to analyze the interactive content in the discussion forum to see what we can find. Okay, so for example, if in a discussion forum, some students say that while the leaf shape of this plant is flat and round, and then this sentence is categorized into P1 because the student is raising a question. If he say, I think it is because the plant requires more water, then the sentence is categorized into P2 because the student proposed an answer to the question. Or if someone say, I think it is because the plant requires more sunshine, then it is also categorized into P2. And if someone say, I think Tom's answer is better than John's, then okay, this sentence is categorized into P3 because the student is trying to compare the answer proposed by the peers. Okay, and then we use a software to compute the occurrence of those behavior. Okay, for example, 33 means when the student have the behavior P4 and follow the P4, the student immediately have the behavior P1. Okay, it occurred 33 times. Okay, so as we can see from this table, the two groups of students have quite different behavior pattern. Okay, in the experiment group, they have more P4 to P1 and more P3 to P3. Okay, but in the control group, they don't have P4 to P1, and they have only one P3 to P3. Okay, so their behavior pattern is quite different. And then we can use the same software to transfer the table, the frequency table, into this table. In this table, this means a z-score. A z-score greater than 1.96 means that the relationship is significant. Okay, so we make a mark here. So we make mark on those values bigger than 1.96. And then we can drop those significant relationships in a graph. We call that a behavior transition graph. Okay, so from these two graphs, we can see the different behavior pattern between the two groups. Okay, of course, I need to tell you that the experiment group have better learning achievement than the control group. So we try to use this graph to explain what happened during the learning process. Okay, in the two groups. As we can see that, okay, the experiment group, the group who use AR have more P2 to P2, and also P2 to P4. What does P2 to P4 mean? P2 means propose and solution, right? When someone raises a question, they try to propose an answer. Okay, so they have. When someone raises a question, they keep proposing different answer, but that is not happen. Did not happen in a control group. Okay. Also, when they propose many answers, then they try to go to P4. They try to reach a conclusion. Okay. And then they have P3 to P3 mean when they keep make comparison, but that did not happen in the control group. So in the experiment group, they try to raise more answer, and also they try to make more comparison than this group. So we use this to explain why this group had better learning achievement than the other groups. Okay. And this is an example of educational computer games. In this game, this is about English vocabulary learning game. Okay. In this game, we try to investigate whether the different user interface would affect student learning performance or behavior pattern. Okay. So in this game, we call it a Cron's guiding strategy based game. Okay. In this game, the students are guided to play the game using a fill-in blank interface. So the game will provide propose some question and let the student to answer the question, but the question is in the form of a fill-in blank game. So the student need to type in their answer. And in the second game, they use the multiple choice interface. So the student only need to choose one of the answer. Okay, from the gaming interface. Okay, so what will happen? Okay, so we use a theoretical background. We call it a one loop, single loop or double loop. Okay, learning. What does single loop mean? Single loop means if a student accepts a learning task, they will directly try to answer the question or deal with the task without doing additional effort. Okay. Double loop learning means each time the student accepts a learning task and try to deal with the learning task or try to answer the question, and the next time they will make some reflection and try to acquire more knowledge before they accept the next task. So in each question and answer or problem solving a step, they will try to go to acquire more knowledge before they make the next attempt, okay, to solve the problem or to answer the question. So this is a coding scheme in the game, okay, embedded in that game. So if the student is trying to read something, we give them the code L. If you try to read some gaming information, we give them another code. Or also, if they accept the mission, we give them a call, and reject the mission, we give them a call. Or if they successfully complete the mission, we give them a call. And if they fail to complete the mission, we give them another call. Okay. So we have several calls to record the student gaming behavior. Okay. So we have two classes of students participate in this experiment. Okay. One class learning with the Cron's guiding strategy based game. And this another group learn with the multiple choice guiding strategy based game. Okay. So we have a pre-test, post-test, and of course pre-questionnaire, post-questionnaire, and we also analyze their gaming behavior. And of course the result is the group learning with the Cron's guiding strategy had better learning achievement than that learning with the multiple choice guiding strategy. Okay, although the game they played had the same content, same learning mission. Okay. The only difference is the gaming interface. Okay. And then we analyze their behavior transition diagram. So I skip those tables. Okay. So this is the group of students who learn with the Cron's guiding strategy. As you can see from this very complex graph, okay, the student after the student accept a learning task, no matter they successfully answer the question or they fail to answer the question, they will try to read more learning content and then go back to accept another task or the same task. No matter they are successfully or they fail to answer the question, they do this. So we call this double loop. They are learning in a double loop. Okay. While those who learn with the multiple choice guiding interface, they just try, fail, or success, or try, or fail, or success. They learn in a single loop mode. Okay, so we use this theory and those learning behavior analysis results to explain why the experimental group have better learning achievement than those in the control groups. Okay. Also, we have this is another game. In this game, we try to let students play the game, and then we have a discussion forums, and then we ask the student when they play the game, they need to collect information to this table. And we try to investigate whether the use of this table would affect student learning performance, also their discussion behavior, interactive behavior, okay? So one group learn with this game and also with this table. And then they discuss when they can make discussion when they try to get the information and to fill in this table. And then the other group, they did not have this table. They only play the game and they make discussion. Okay. We also record the discussion, the interactive content, and then we try to use this coding scheme to analyze the interactive content of the two groups of students in the discussion forum. Okay, so one class of students learning with the game and the table, and the other group of students just learn with the game and the discussion forum. Okay, so as we can see from this graph, okay, this graph is the behavior transition diagram for the experimental group on student. Okay, and as we can see, the students in this group have more observation and more comparison. Okay, they make more observation and make more comparison during the gaming process. Okay, also they have more behavior of searching for clues, okay, during the gaming process, but not those in the control group. Okay, so we use this graph to explain why the students who learn with the game and the table, when they need access to collect information in the game and collect the game and organize them in a table, can have better learning achievement than those who only play the game. Okay. And how can we do the analysis? Okay. Of course, we did not count the number of occurrences of each behavior manually. Okay. So we use GSEQ. It's a sequential behavior pattern and analysis software. It's a openware. Now it is version 5.1. I think you can download this software from this website. Okay, so there's a website for GSEQ. Okay, so it's open for everyone, so we can download. This is a very simple, small program. I'm not going to teach you how to use this program here, okay, but I just want to show you how easy it is to use the program to make the analysis, okay. So you only need to follow a step, okay. You just, first of all, you need to prepare the system log or interactive content, coded the interactive content in a text file. And then you can open the text file from this program. Okay, let me skip it. Okay, this is what the data look like. Okay, first of all, we need to announce that we have 5 behavior, A, B, C, D, E, and this is the log of student 1. Okay, the sequence of the behavior. Student 1, and this is the student 2, student 3. We can just put all of the student behavior in a sequence. Okay. And then, okay, and then we just do some option. We just select some function, and then we just try to we click on this button, join the frequency, and adjust the radius. And that means this score, computer this score, and then we got these two tables. Okay, this is the first table we just show you. Okay, the number of occurrence from one behavior to another. Okay, okay, and this is the z-score table. So based on the z-score table, as I have mentioned, if the z-score is bigger than 1.96, that means the relationship is significant. So we can drop it in the transition behavior transition graph, right? We can have this graph, and then we can, okay, if we do the two groups, and then we can compare the behavior between the two groups, and then we can use the graph to explain what happened during the learning process of the two groups. Okay. I have also prepared some future research issue. Okay, but as I think that the other keynote speakers have also talked a lot about this issue, so I think I can skip this part. Okay, I will leave this PPT to you. Okay. Also, if you are interested in coding, develop a coding scheme, or you are interested in using the software to analyze student interactive behavior or student learning behavior, or even gaming behavior, I would like to recommend that you read those papers. Okay, and thank you.